In this video, we are going to derive derivatives of trigonometric functions using our first principle. Okay. Now we know when we put del y and del x directly, it always comes out to be 0 by 0, which is an indeterminate form. Now, whenever we encounter indeterminate forms in trigonometric functions, we should remember we'll have to use this formula to eliminate the indeterminate form. So our main objective will be transforming our del y so that our final limit will take this form. Okay. This will be our main objective here or main motive here. Okay. So let's see first calculating derivative of sin x. That is tan sin x by dx. What will come out to be? We know from first principle. So first we let y equals sin x. Then we say let del x be a small change in x. This is what we always do while using first principle, and call del y with the corresponding change. Right? So these are corresponding change in y. Now we find del y. Y plus del y will be sin, we place x plus del x in terms of x. So here we take out our y and move it to this side, so it becomes minus y. Therefore, del y will become sin x plus del x. Another thing here to remember is whenever we are dealing with derivatives of trigonometric function using first principle, we'll always have to transform sum or difference into our product form using trigonometric formula. So we'll have to convert difference into product so that we can apply this limit here. Okay. So this is sin this minus sin this. This is sin c minus sin d. If you can remember correctly, the formulas from trigonometry class 10, you'll know this is equal to sin c minus sin d, which is equal to 2 sin c minus d by 2 cos c plus d by 2. So it will be 2 sin c, these are c, these are d. So c minus d will be x plus del x minus x divided by 2. And here it will be cos c plus d. Our c is x plus del x plus d is plus x. So we manipulate del y earlier so that it will be easy when you replace in first principle. So it will be 2, x will cancel out, sin del x divided by 2, and cos, this is 2x plus del x divided by 2, which will be 2x divided by 2 plus del x by 2. These two will cancel out and it will be x plus x by 2. So I'll write it here, x plus del x divided by 2. So these are del y. Okay. After you transform into product, we can now use the first principle because it will be easier now. So from first principle, and let me write it full word. From first principle, dy by dx is equal to, we just write down the definition, and now we replace del y. del y is this term here. So it is 2 sine del x by 2 cos x plus del x divided by 2 whole divided by del x. Okay, divided by del x. Now remember, we said earlier we have to use this formula whenever we have to find derivative of trigonometric function. Right. Now let's see here. Sine del x by 2. So this term is approaching 0 when del x approaches 0. Right. We put del x 0, sine 0 becomes 0. So this is the main reason for indeterminate form. Right. 0 divided by 0. So we have to use these two and eliminate this indeterminate form. How can we do that? So here it is sine x. So here is x. Here is del x by 2. So you transform it into del x by 2 just by dividing by 2. And to balance it out, we need a 2 here. So now this limit will be 1. And this will be our 1. So this 2 will cancel. This limit is 1. And we put 0 here. So it becomes cos x plus 0. It becomes cos x. So derivative of sin x. D sin x divided by dx is equal to cos x. This is our first formula. You'll have to remember it. Now we are going to find derivative of cos x. So again, we'll use first principle. We'll let y equals cos x and say then del x be small change in x and del y be the corresponding change in y. Corresponding change in y. Now we find del y. We put x plus del x in place of x. Again, as earlier, we take our y on that side, so it becomes minus y. Therefore, del y becomes cos x plus del x minus y is cos x. Right. So again, what we said earlier, we have to transform our difference into product. So we'll apply the trigonometric formula cos c minus cos d. And we know cos c minus cos d is 2 sine c plus d by 2. And here it's d minus c by 2. Or we have another formula, minus 2 sine c plus d by 2 sine we write it c minus d by 2. We're just changing its sign, so a minus comes here, and sine minus theta is minus sine theta, so the minus comes here. We'll use this formula, it will be easier. So this becomes minus 2 sine c plus d, means x plus del x c plus d divided by 2. And here sine c minus d divided by 2. X cancels out. As earlier, this will be, this is 2x plus del x by 2. It means x plus del x by 2. So it will be x plus del x divided by 2. It will be sine del x divided by 2. Again, it has been transformed into product form. Now, we simply apply first principle. From first principle, dy by dx is given by what? Del y by del x. So you place del y by this term. It is minus 2 sine x plus del x by 2 sine x by 2. Now we need to find due to which term the 0 by 0 form is coming. So here, if we put del x equals to 0 in this term, it will be sine x. So it is not going to 0 when del x approaches 0. In this, if del x goes to 0, it becomes sine 0, which is 0. So we have to use this one. Limit x approaches 0, sine x by x equals 1. So here it's del x by 2. So we'll have to make it del x by 2. To balance these two, we need a 2 here. So now this limit will be 1. Okay. This will be 1. This will be 1. And these two will cancel out. So when we put del x equal to 0 here, so it will be minus sine x times 1 is itself. So derivative of cos x with respect to x, d cos x by dx is minus sine x. Now we are going to calculate derivative of tan x. For this, I won't be using first principle because it will be lengthy. I'll be using the well-known quotient rule. Okay, because we know the derivative of sin x and cos x, we can write tan x as sin x divided by cos x. So we'll use the quotient rule, du by v rule. So we know du by v is given by v du minus u dv divided by v square. So if here is dx, it will be dx du by dx. We'll use this quotient rule. So now d tan x by dx, it is now v is our cos x, du means d sin x minus u is sin x d cos x whole divided by v square means cos square x. So it is the derivative with respect to x, so we write dx here. Now we know d sin x divided by dx, it is cos x, d cos x by dx, it is minus sin x. So when you multiply cos x and cos x, it becomes cos square x. Here you have minus sin x means plus sin square x. And on the denominator, we have cos square x. This is 1 divided by cos square x. So it is sec square x. Therefore, derivative of tan is sec square x. Similarly, you can find the derivative of cosec x. You can write it as 1 by sin x. And again use the quotient rule. Or maybe sec x is 1 by cos x. Again you can use the quotient rule. And for cot x, again you can use 1 by tan x and apply quotient rule. You can also apply chain rule combined with the power rule by writing it as sin x power minus 1. So you can use whatever you like, whichever you find easier, but try it yourself. Okay, we have found the derivative of sin, cos and tan. Sin x is derivative of sin x is cos x is minus sin x, and tan x is sec square x. Now I wanted to try for cos x, sec and cot. Thank you.